Okay, so hey, and welcome to the containerized software on the OSPool training. Um, so my name is Mats Runch. I'm one of the facilitators for the OSPool. Also on this call, we have Andrew and other people here that you might have interacted with, Christina, Danny, and Amber. And this training here is an interactive training. So feel free to interrupt me at any given time. You can either chat or you can unmute and you can just ask questions that way and stop me that way. So feel free to use this. You can do reactions. We really encourage interactive participation. We are also recording this training. If there are questions that comes up during that, and we can edit the recording and edit those out. So don't be shy. Feel free to participate. The agenda that we have today is as follows. Why using containers on the OS pool, finding existing containers, building containers, custom containers, and that's specifically using Apptainer, test containers, and use containers in your jobs. So first, remember when you get your account and we showed you this map about the sites contributing to the OS pool. So these are all places where your job can land. And why that's important here, right, is that these are all at different institutions, different local policies, different administrators, and at the end of the day, what that means for your job is that they could land in slightly different environments, like depending on where they get matched. So we want to be able to protect ourselves and protect our jobs and make sure that we get a consistent environment. And that's one of the containers, that's one of the things that the containers will do for you. So, consistent environment, right? We land on a machine. We don't really worry about what that machine provides because we all have our container. And we have a complete environment, and we're going to talk about these more in detail here in a second. But the container also gives you a complete environment, right? You don't have to kind of puzzle one together from what's on the site and what you're bringing. And there's also a reproducibility component of containers where, hey, you have a perfect recipe of the environment that you're expecting. And so that's easy to share that environment. You can, provide it to your collaborators when you publish and so on. So there's a little bit of a food analogy here. And the idea here is, comparing cooking in your kitchen to other places. So if you're cooking in your own kitchen, it's pretty easy because you know where everything is. You know what components you have, like ingredients you have, and you know where all your tools are. You know the equipment in the kitchen, right? So it's a very familiar place to be. And running code on your own computer is very similar, right? You know what you have installed, and you know where stuff is, you know where the directory structure is, and so on. And at the end of the day, if there's something else you need on that computer, well, you just install it, right? You can modify this computer, you're in full control. Now, if you have ever cooked in somebody else's kitchen, you know how much time you spend looking for things, right? You're looking for maybe a spatula or something like that. You have to go through a bunch of drawers, and then maybe you find out they don't even own one. So, being in somebody else's kitchen, right, is you spend a lot of time trying to get your environment, and you spend a lot of time just overhead for in the instead of doing the real work. So comparing that to using somebody else's computer, and this is hey, if you just have to use your colleague's laptop or something like that for a little bit, or you have a loaner coming, and you spend a lot of time looking around, right? You're looking, okay, where's Python, and is that the right version, and does it have the right modules that I need? and there's anything odd with the environment, right? Any configuration things that I need to know. And then at the end, if you need something else, you're not really probably not allowed to make changes to that, right? Like this is something that's temporary, and the owner of that computer doesn't want your changes anyways. So the solution here is thinking like a backpack packer. You bring with you what you need, and and for certain kinds of software, that's really easy, right? Maybe that's an executable, or maybe it's a script. Doesn't really need anything else. So, like in this case, like that backpacking stove is very, very self-contained, right? Like it doesn't depend on infrastructure or anything like that. So it's easy to carry around and put down wherever you want it to be. But our software stacks are kind of complex, and there's more and more dependencies. We have more and more environments where the instructions are, hey, install this high-level tool, and it will bring in a bunch of modules. So using a caravan with a kitchen is kind of a good analogy here, right? We can just stuff everything we need into this caravan, and wherever we take that, we have everything with us. And that's what containers do for us, right? They are they contain all the stuff that we need. So that includes versions of particular software, it includes the dependencies of that, and it's all fully resolved and all the same wherever you bring that container. So again, think back about that map that I showed you. When we land on any of those nodes with our caravan, and we have everything that we need. Now, there are many other container motivations, right? We talked about using it for our own software. But if you're running jobs on the OSPool and you don't specify container, there's a really good chance that your job is running in a container anyways. And that also comes back to that map, right? We're saying, hey, if we can run containers, we're going to use a set of default containers, and we're going to make this environment as seamless and as consistent as we can with those containers. So again, the point is, even if you don't specify container, very good chance that your job is running in one. The second bullet here about user-defined images, that's really what this is about. This training is about. We are going to show you how you can build your own container and use that in this pool. And the third bullet here about special environments like GPUs. Um, it's that those kind of hardware environments usually comes with an even more picky software stack, and thus the containers are really even more important, right? Like running GPU jobs without a container is really, really difficult because of the kind of software and hardware interconnection. And then below the line here is some motivations that we have as operators of the pool, right? So processes isolation and file system isolation. And what that means is that when your job is running and you're running in a container, you will only see what's in that container, right? You can't see other things on that host. So this is it's part of the security model that we have on the pool, that your jobs are contained. You can't peek at other people's processes and files. The container technologies, there's actually many container technologies, but there are a few that are kind of dominating the scene. And Docker is the one that most people have heard about. It's been driving a lot of the kind of containerization of the world. And it's still used a lot in places like microservices. However, it's not commonly used in scientific computing. And the reason for that is the security model. And so Docker kind of has this approach that it's a very trusted process in the machine, and you can switch users and things like that in the container, which opens up a little bit of a security issue when it comes to using it on a shared computing system. So instead, what we're seeing is the Singularity and Aptainer ecosystem. And these are so Singularity, Aptainer is a fork of Singularity. And so they basically the same thing. The commands are almost the same. They have some some small technical differences, but most of the time we can use the images interchangeably between the two. And Singularity and Aptainer is also what you will find, most likely find on your local HPC cluster or campus cluster. These are very, very common tools in all of high performance and high throughput computing. It's not OSPool specific at all. And the big difference here really with Docker is that when you run something in an Aptainer Singularity container, you are running it as the same user started it. So this is why this is very popular in the shared file system or shared systems, right? That there's no user switching going on or anything like that. It's just one-to-one mapping between the host user and the container user. And so we'll focus mostly on Aptainer today, but we can. One of the really neat features of Aptainer Singularity is that they can use Docker images um, um, as well. All right, so um, one an important part of containers is building versus finding, right? So if we can find a container that's already doing the thing that we need it to do, why build it, right? And a lot of times what you will end up with is um, that containers are published or maintained by upstream, providers. So, for example, if you want to, and I will show you an example here, but it's a very common thing that software providers provide Docker images for you. So some of the existing containers that we have, I'm going to click on this link so you can see what they are. And the first one is OSG provided. We have a set of base images, and these are in the OSG documentation. I'll make this a little bit bigger. So there's a list of containers. So let's say you want a Rocky 9. Well, here's a container for you, how we built it, and things like that. So there you can find all these containers pre-made. We have some of the basic tools, some of the basic languages, um, some of the product images, and some other tooling that you can find here. So there's a bunch of pre-existing containers that we built in the OSPool. Now, the second list here is a set of images that are synced to the OSPool. This is kind of an older model, but you can look through this list and find a very good feel for what type of containers that people are syncing and are using. And especially if you're part of a bigger collaboration, they might have them in here, so we can look at uh, where's a good example? Like Fermilab, for example, published some of their images. Jefferson Labs. There are some of the bigger labs and some of the bigger collaborations and maintain their images this way. And then the last place to find the containers is Docker Hub. This is really a big software catalog. And what's neat about the Docker Hub, again, is that it's very, very popular. You can find almost anything here. So an example, let's say that I'm using the Rosetta software. Rosetta. I'll find a bunch of different containers here, including, the upstream one. So this is what I meant that the project that makes this software, they also provide a container for it. And so this is obviously a, a pretty safe and well-tested uh, image that you could use if this is the software you're using. And this is true for a lot of different software. Docker Hub is huge. All right. So those were the pre-existing images, and the other thing you can do, I will show an example here later, but you can take one of these images and then build on top of it. You don't have to use it exactly like they provide it, but you can take it, modify it, and for your liking. Okay. So, what if we can't find an existing container that we like? Well, we can build our own. And a lot of the users that we work with, they take what they have done, maybe in a local environment, like maybe they have um, Python virtual environment or something like that that they use when they do the local deployment and testing and building, and they make that into a container. So that's what we're going to show you how to do. All the stuff that I'm talking about here is in the documentation, and I'm going to put a few links here. First, I'm going to put the slides in chat. Wanted. Okay. I don't know why you do that. Mhm. Yeah, so that's what Andrew is talking about is really important also, trusting the software. And that's another reason why by going to the upstream provider, like so let's go back to that example again before we building our software. So let's go back to Docker Hub. So when you search here, right? Again, as I said, there's a bunch of them. You will see a lot of different results. So people might have taken this upstream official Rosetta container and then built their own, but it's harder for you to trust that, right? Because you don't know why what the changes they have made in that container. So it's the same as you just downloaded random software from the internet, right? You have to be you do a little bit of vetting, a little bit of validation that hey, this is actually what I want to run my science. All right. So as I said, the all the things I'm going to show you here is in the OSPool documentation, and there's a link there for containers, Apptainer Singularity. If you want to follow along here, you need to be able to log into one of the access points. All our access points do have Apptainer. If you're at your own, lab, it may or may not have it. But as I said, all the OS pools, so AP40, 41, and so on, they all have it. So if you have one of those accounts, log in or just follow along when I show you how to do it. Um, so when we get to this access point, the let's start with the directory, and then we create this file. So I'm going to go about here somehow, and I'm going to switch between my shell and my slides. Okay, like this maybe. All right. So I'm on AP40. I'm on AP41. All right. So I'm going to make a directory, call it container training or something like that. Training. Let's cd into that. And in there, we're going to create this file. Right. So this is an apptainer slash singularity definition file. So this is a starting point for the container we want to build. So we're going to call it, what did we call it? My container.def. Def. Right, we paste that in here. And so let's talk about this definition file a little bit before we build it. And the different sections, so you see there's like a percentage sign post. So this is a section in this file, and there's a few other sections that are good to know about. So one of them is the environment section. And the idea here is that the post section is what's building the container. So we're going to, run the commands in post section, and then they only done once when we build the container. But every time we start that container later, this environment section is going to be sourced. And so this is a runtime section, right? And you don't really install anything in here. But what you do is you can set up the environment. So if in this case we have a conda environment in a specific location, so what we want to do is we want to activate that conda environment. And that means every time we start the container, the same conda environment is activated. Another section that's good to know about is the percentage files. And this is when you build your container, if you want to inject files into the container. So for example, let's say you have a repository that you're building this, you want to build a conda environment, but you have an environment file. And that environment file is needed down here in the um, um, post section, right? So what this does is it takes the file from the current working directory and puts it in the container for you, so you can use it there. And you can do this. Most of the time we do this because of things like this, in injecting source, injecting files at build time. You can also use it for data, right? So if let's say that you have a common database that you always want to be in the container, you can inject that with the files section. Another common question is where on the file system should I be installing my software? And there's a few places where you do not want to do it, and that includes home, root, and serve. And the reason for this is that home and root, like home specifically, right, is it's unique to the machine that you're running on. So you have a home directory on the access point that is not going to be accessible on when you run the container somewhere else. So stay away from home. Same with root. You're not going to run as root, so root is not going to be visible to you. And slash SRV is a lot of times it's used by the container as a starting directory. So we don't want to put stuff in there either because they will also be hidden for us in that case. So what we do recommend, and this is basically even standard Linux file system best practices is to do it in slash opt or slash user local. Those are great places for your own software to live, and they will always be available in a container for you. All right. So another thing that we have to be a little bit careful about, and that is that these containers, especially during build time, they use some disk space. And when we all do this in the same machine, sometimes there's not enough space in slash temp, for example. So what we wanted to do is use these commands. Oops, and I'm going to paste them in chat as well. So what these do is really just moving Apptainer's temporary directories to your home directory, and copy that and to put them here. Right, so now I have my environment. That's not needed on all access points, but it's a good practice to do it. Okay. And let's look at our the definition file that we created here. So I've set the slides back. Yeah, should we do this here? Can I get this bigger? No. All right. We can look at that container definition again. My container def, right? So this is a simple version. We do not have files. We don't have environment that we talked about. All what we're going to do is use some system tools. So apt-get is the package manager in Ubuntu and Debian. And the reason we're using these is from up here because our base image happens to be an Ubuntu image. If your base image was rel-based image or something like that, you would use RPM or yum here instead. Um, but basically, it's a set of commands to get us to the container that we want, right? So we want to start with this Ubuntu base image. We want to install Python pip and NumPy, and then we use pip install to install the actual tool that we're looking at, which is a silly Causa library that we'll be using here in a second. Okay, so now we get to the fun part. Now we're going to build this. So again, this command here, paste that in, following along. And so if we run this, so this command, right? Apptainer, that's it, the container tool we're using. We wanted to build, and we want to build this image. This is the CIF format is the standard format for Apptainer Singularity images. And here's the definition file that we already have. So we're going to run that command. And you'll see the first thing it does is fetching an image. It is fetching the base image and extracting that image. And this all happens on the file system. It's going to take a little bit of time. Should be pretty quick though. Yes, Jam, go ahead.
Yeah, so thank you. I am actually confused. Where are you running this command? Is on the so I am on app 40,
Yeah,
uh, and I create this temp directory, but then where do you run this command?
yeah. So okay, let's take a step back. I'm going to switch to a different window here. All right. So what I did, right, was I logged into the access point. So in my case, that is AP40. IP40 on actually. It doesn't matter, whatever one you're using, right? You log into that access point, and in here I created a container training directory, right? And in that container directory, container training, that's where I created that definition file. Did that answer
Thank
your
you.
question?
Yeah. It answered my question. Thank you so
Yeah.
much.
Right. Um, yeah, and this should really work on this part is not unique to OSPool, right? Like this is something you could do on your HPC machine or any other basically submit an access point that you have. All right. So going back here to what happened. So my extracted the image, running post, right? That was our section. So it did apt-get update, which is it updated the package cache. It did apt-get install Python and Python pip and Python NumPy. Okay, and then uh, where is it? It's hard to read these sometimes. There's very little. Oh, here, pip install Causa, right? And then it created a zip file. So if we look now what we have in this directory, now there's two files. We have the definition files and we have our container file. Um, so that was successful. And what we're getting to now is now what happens when I have my container built. I can do two things with it. I can test it locally on the access point, and I can use it in my jobs. So testing it on the access point, we're going to run a command called apptainer shell. So it's going to be apptainer shell, and then that container name, right? And what that does is it will give me an instance of this container running on the access point. So I'm going to first clear here so we see what happens. All right. Again, I'm in this container training directory. I see my image here. I'm going to run apptainer shell and then that name. And it doesn't really say much what it's actually doing. But it started this container and it dropped me into it, and now I'm in the container. There are some really interesting things that happens when we do this. So first, my home directory is automatically mounted. So even though I'm inside my container, I have access to my home directory, right? So I can look at my files. I'm still in the same place. I still have the same files. And this is really convenient when you want to test the container because you can just start it here, you can get this environment, and you can interact with your own data that's in the home directory. This is obviously only useful when you do the shell part. When you start running jobs, you're not going to have access to your home directory anymore because of the distributed nature of the OSPool. So, but during testing, it's very, very convenient. And now we can test this, right? So we can test this. We can run we can run Python. We can import Causa. And I'm going to type this in here also. So I'm going to run Python 3. Import Causa. Right. And now I had to cheat a little bit because I have to get this one also. Right. So then we can use this library, and we can run hello world, right? So this is all this library does. But the point about this, right, is that I now have access to software that I did not have access to on the login node itself, right? I could not do this on the access point. I can show you. So for example, here we are on the access point. We do Python 3, we do import Causa, right? No such module. So what this demonstrates is that the container gives us this, even locally, right? Give us the ability to use custom software that we didn't have to really install on this system. It's temporary here in this container. Um, when you want to exit, let me see here. All right, when you want to exit, you just do exit, right? And no, actually quit maybe. No, Control D, sorry, Control D. All right, and Control D again. And now I'm back out on the access point, like nothing happened, right? So yeah, this is a very convenient way of testing your container, making sure that the environment is what you expect it to be. And once you have done this, then you're ready to start using it in your OSPool jobs. So let me do a few more slides before that. Again, here is an example of why home, like having home is really neat. You can also do the reverse where you can, in your container, you can create a piece of data. So for example, you can run your code, create a piece of data, and then later when you look in the home directory, the data is still there. So after you stop the container even. So this is very convenient. Hi, any questions before we go to using it in our jobs? Everybody understand how we build containers?
Yes,
And
can I ask a question? Oh, I
yep,
didn't
go
raise the.
for it.
Yeah, yeah, sorry. So in this file that we create this container, like we have like Python and NumPy and Causa we install.
Hmm.
Uh, but there will be other thing get installed because of these libraries. Like depend, like for example, I want to install KDE so it has some SciPy and other things. So those will be
Yeah,
automatically done.
yeah. So it depends a little bit on how you do it. But let's look at our container again. Um, okay. So this is a pretty simple library, right? It doesn't really have any dependencies. But if you did something more complex here, I mean, we can do something like PyTorch, right? That will have a lot of dependencies, and that will all be resolved by Python in this case. So you can install as much as you want here. That's not a problem. But the actual dependency resolution will be from pip in this case.
So question is what is the difference in just a virtual environment and this one? Like this has like a container or something. I mean
Right,
I'm little
right.
bit I'm not expert, just asking.
No, it's a good question. So the question is, now when I have this container, how is this different from my virtual environment, right? And and a big part of it is that this one is really, really portable. Like your virtual environment, you could make a virtual environment and then, make a tar file or zip file of that and move it somewhere else. Then you have to reinitialize it, and it may or may not work, right? Because when you do the virtual environment, what really happens is it will look at what's on the system and then build on top of that, right? Now, when you move that virtual environment to a different machine, maybe that baseline is different, and there will be a gap between what you have in the virtual environment and what the base system kind of provides for you. So even though the virtual environment works, it is a little bit trickier to do. And in our documentation, so if you go to the user documentation here, we do have venv examples. Virtual env. There should be something virtual. Wanted. Right, let's do Python 3 then. Python. So there are examples of here. Right, so that actually goes to container running jobs.
I wonder if we removed it
Yeah,
in
maybe we
favor of
took it away.
container.
But yeah, you can,
It could
right? So you
also be
Yeah,
can,
buried in a
but I got
tutorial
the
somewhere.
answer. Thank you so much. This is
yeah,
very, very useful.
right. And
Excuse.
go ahead.
Sorry, finish. I have some other questions.
No,
Sorry.
I'm saying this is not a problem unique to Python, right? This is in if you build an executable that links to local system libraries, you move that, and then they will also have, a base system problem. But in a container, everything is resolved and always the same. So that's the real benefit. So now go ahead. Who else was that was talking?
Oh, this is Julia. I have a question about the fake root permission. So I know somewhere like a apptainer build need a fake root permission for like a building from definition file or a sandbox. Can you explain a bit more, like what's allowed, what's not allowed?
Yeah, I wish I knew. This is something that has gotten better over time. Um, if you're a long time OSPool user, you might remember that we didn't allow this before. Like you couldn't build a container on our machine because it had some tricky some tricky permissions. But really, what's happening here, right, is you remember when I said that this is all running as the common user. So um, if in that definition file, we do stuff like apt-get, right? This is a super user. This is root command. So how can we do that in a container that we're running in user space, right? And that's what this fake root command does. It's usually transparent. I don't think we had any errors about that, but usually it is. And what's interesting about this, right, is that so it looks like we're tricking the file system really to think that we are installing this as a privileged user, and then we get this zip file, right? The zip file that we produced, and this is read only. So if we look in this file that we produced, I'm going to do the apptainer shell thing again, right? Like this has a full file system, and it has all these different, system tools, but you see the ownership is my user. So it's a really kind of weird trickery, but this is how we can use these images so kind of thinly on top of an existing operating system. Julia, when you built, did you see a fake root issue, or did you just know this from past?
Oh, I read the website talking about need a rate the fake root permission in order to
Uh,
build from uh, sandbox or I read the Apptainer website
yeah.
documentation.
Yeah, so our systems are configured for this to work. It shouldn't complain. Now, this mockery that we're doing, um, there are some software that complains about that kind of detects that something is going on, and they will give you an error. But there's very few left of those, so I don't think you'll run into it.
Okay, thank you.
All right. Um. Okay, where were we? All right. So running this. Any other questions before we start running jobs with this? All right. So, um, so now we have the container. So what do we do with it? How do we get it into our jobs? And um, first, we have to learn about something called OSDF, the Open Science Data Federation. And the reason OSDF is important is that the images that we're building, like this CIF image, it can be a little bit of a size, right? It's not super big, but it's not uncommon that it's a couple of gigabytes or 2, 3, 4, 5, 6 or so gigabytes of data. And what we see is that a lot of most users they reuse that image for older jobs. So every job you run needs to get that little image, and it's just a lot of data transfers for to get the data to those compute nodes. And OSDF helps here. It's really a caching network that will cache and distribute and transfer these containers in the most efficient manner. So what will happen is under our access points, we have a special directory called /OSPool, and then AP like 40, 41, whatever you have, /data/ your username. So everybody should have this directory. And anything you put in that directory can then be referenced by prepending it with OSDF ://. So you see this part here is the same. The OSPool AP40 data username is the same. And you put it, anything you put in that directory is then accessible via OSDF. OSDF is authenticated, so that means that you're putting stuff in here that's still only visible to you or your jobs. But this is really the most efficient way of doing the data transfers. Um, Something that's super important though is one of the things that makes OSDF work as well as it does is that it's caching stuff really, really aggressively. And it really just looks at the file name to know if that's a new or an old file. So that little V1 that I have in the container here is really important. We want you to, every time you build a new container, you kind of give it a unique name, and that will prevent some weird caching things to happen. If you do not do this, if you just named it the same container, my container.cif every time, you could have jobs start up, and depending on what cache they were using, they could get the old version or the new version of the image. So it's really important to keep this unique and update it every time you make a change to container. So let's do that. Let's move our container into our right location. Right? So again, I'm going to clear here. So I'm in my home directory. I built that CIF file. I'm going to move it, or you can move a copy. It already has the version 1, so that's good. And I'm going to copy that into the OSPool AP41, which I'm on, data, and then my username. So I'm moving that into that directory. We can look in that directory. I probably have a lot of stuff in there, but right, there's a bunch of other stuff in there. But again, there's my container, and it's ready to be used in a job. The way we're going to use this, let me see here. So yes, we're going to put this in our submit file, but we'll get to that in a second. Just move the file for now and make sure it's in the right location. The other thing that we want in our job is we want a script, right? So And this is the little tool that I want to use. I'm going to copy this and I'm going to make a new file called lolcow.py. And remember where I'm at. I'm in my container training, lol, cow.py. I'm pasting that in there. We can change mode that so that it's executable. And stop me here if you have any questions. So what we're doing is we're setting up a job that will use that container to run this script. And again, remember what happens when we try to run this script? Well, you can't find cowsay because we're not in the container. So this is what that's going to demonstrate. Okay. Next thing we're going to do is have a submit file. And we're going to talk about that, but I'm going to create it first. So I'm going to call it job.submit. And here's where you will have to modify at least some of the things. That URL up here, like that OSDF. So container image specifies the container image we want to use. I'm on AP41 again. My username goes here. It's range. All right. So if you look at this rest here looks like a normal job, right? Like there's nothing special about that. The container image does two things for us. It tells the system where can I find the image for it. And then what it does is saying every time I run this job, start this container and drop the job into it. So you don't have to run any apptainer run or apptainer shell or anything like that. All you have to do is specify a container image, and then the rest of it is automatic. All right. So we'll look here again, Condor submit. When a OSPool job uses container image option, will automatically transfer container image, mount the job's working directory. So again, we don't have the home directory, but we do have the current working directory. And so if you do, file transfers or anything like that, it will still be available inside the container. And then runs your executable in the container. So don't do apptainer run or anything like that. Okay. So let's run that job before we go any further. So we're going to do Condor submit, job submit, submitting. Okay. And we can look at Condor queue, just like a normal job, right? We can look at it and see what's going on. We'll wait for that job. Yeah, Jam.
Okay, I think maybe I lost you. So you are not in the apptainer at the moment. You're running it in the
Yeah.
directory, right?
Right.
Okay.
The
Just
apptainer
to make sure.
shell is only for testing it and then we exit. Right? And we exit with a control D.
Okay, yeah, got it. Got it. I was
Right.
just a little bit
Yeah.
confused that if you're
And
running on
and
apptainer.
it's a good question because what happens, right? Let me show you something. So um, I have Condor Q, like one of the tools that we're using here, right? But look what happens when I run apptainer. So now OSPool data, no, AP41 data. Um, so when I go into container, right? And then I run which Condor Q again, like I don't even have that command. Right? Because what I did is I've moved inside the container and it's a different set of tools and stuff available in it. That makes sense?
Yes, thank you so much. Yeah, thank you.
Right. So control D out of that and make sure that you get the normal, AP prompt, whatever it looks like for you. If you have to bind that other dir, so you can. So if you use apptainer in, for example, your campus cluster, you can mount other directories. You cannot do this in the OSPool jobs. But an example of this is, so let's say I'm going to clear this. I'm going to go back into my container and I say, hey, OSPool, the directory we were just in, is not accessible, right? What I can do is I can start this again with the bind flag. I think it's capital B, right? Let me see. And now I have OSPool available to me. So you can bind with this flag here, the capital B for binding file systems from the outside into the container, but you are not allowed to do that in Condor jobs. Okay, and so let's see how our job did. Mine is still idling. Why is that? Just making sure I have not did anything bad. No, it's just waiting. Okay. We'll come back to the job and we'll look at it here in a second, but I'm going to do a few more slides. We'll wait for that. So as a reminder, best practices in using containers on the OSG. Don't use the latest tag in images. So this is actually not the OSPool specific, but to use version number specified. And what this is talking about is if we go all the way back to Docker Hub, and we're going to see if the Rosetta, we're going to go to the same example that we did before. So one of the things that happens to these containers is that they get tagged with different versions. And you can see that also in our definition file, for example. So the tag is whatever is behind that that colon, right? So what you're saying is I want this Ubuntu 24, and I am using the latest here, which we said we shouldn't do, but in this case, the versioning is actually over here. The point that what we don't want you to do is to pick something here, right? Like so they have tags for different versions. So they have like these are the versions, and they also have a latest tag, right? But what happens with the latest tag is that it's moving. So let's say that you built a container today and it's working great and you have everything working and all good, right? And then in a month or two, you rebuild that container. You haven't changed the file because guess what? It just said latest, right? But this whole base image has changed underneath you. And so maybe that breaks stuff. Now you have no way to kind of reproduce the environment that you wanted to be able to reproduce. So instead, what we want you to do is stuff like this, right? Use a version, and they actually give you the version here, right? So they say, like in here, you could just say, right? Use this part, no, not Docker pull, sorry. Right. So this here is the specific version of this container, and now this file is reproducible. All right. Okay. The other thing, best practices using unique image file names. That was the version 1, version 2 thing that we talked about. So yeah, go ahead, Jam.
Yeah, so actually I didn't notice this before. So we are copying some container from this open science grid in this tutorial. But what if I want to have my own container? So I have to, I don't know how I will get it there
Yeah,
or how it
that's
works.
just
So
a base container. So
okay.
most people would just pick something like this. So like this one, like the Rosetta one here, it only makes sense if you're going to use Rosetta, right? But let's say that you want to just use a base container, base Ubuntu. So you can go to something like the Docker Hub and saying, hey, I'm using Ubuntu 24 on my laptop. I want to have the container to be the same because keeping the environments the same makes it easier for me to kind of debug them. So you type in Ubuntu, and there will be a lot of them, but yes, there will be an official one, right? So you go to Ubuntu, you look at their tags, and they will have a lot of tags because they build a lot. They do have the latest one, but remember, don't use the latest if you don't have to. So we can search, right? There's a lot of, so we can search for Ubuntu 20, oh, sorry, 24. So here's one tag, and they give you the little image here. So we can go back and we can say from Ubuntu 24. So now this is the base image, and then you can apt-get install. And you can look at these images also. So another thing that happens, um, you can do Ubuntu, like you can do aptainer shell. So let's say you wanted to try that Ubuntu image and see if that's a good fit for you. You can just do Docker, specify it's a Docker image, and Ubuntu 24, and that will now download that image and drop you into that one. Something to note here, right? 24 megabytes is tiny. Like these base images, they have almost nothing, right? So depending on what tools you want here, it might not even have wget, right? So these are small images that you have to kind of build up to be your be what you need it to be. So if you compare that Ubuntu 24 to the one that we had, which was, sorry, I'm going to jump around a little bit. Where is it? Up here. So this one is Ubuntu 20, but it's almost the same thing. Um, and the reason we have these is that these are um, a little bit more complete, right? So you see, this was, you know, 660 megs versus 28. So it's a bigger base image, but it has more things in it. And it has, things that are very common. Like, even though we call it like the OSPool, it's really kind of a scientific computing image. There's a bunch of stuff in here that we think are very useful for scientific computing. And we can look at this in another way where we can look at um, how do we build these images? What's the definition for these? Well, hopefully I have one here. Oh, so this is a Docker file, but it's the same thing. So you see, we apt-get install all this basic tooling. So compilers, some basic libraries, some basic Python stuff, some basic R stuff, and editors and things like that. And the reason we do this, right, is that this makes the container um, good base container for most of our users. Like this container is probably good for 90% of our users. And while this tiny one always means you have to start building stuff into it. Does that make sense?
Yes, it makes sense. Now I have a question. Sorry, I'm asking a
Yeah.
lot of
No,
questions.
go. This is what the training's for.
Yeah, so job.submit we call container image, right? We call this CIF file, right?
Mm-hmm.
So I think what I just want to make sure. So we need to you follow the step to create this my container version 1.cif file, and then we don't need to go to container, but just we can call this in our script. We can call, like, when we have to submit the job, we can call this container image, and with our like correct address, and
Right, this
this
here, right?
cif
That's
file.
what you're talking about?
Yeah, that's
Yep.
all. Yeah, so
That's
that's
all you
what
have to
is
do.
okay. That's
You
all
don't
I
have to do
wanted to make
apt
sure.
or anything. And as a matter of fact, let's see if our job is done. Mine is still idling. Why is that? Either the system is really busy or I have something in it that makes it not want to run. I don't know. While we wait for that, let me find another job that I might have been running recently. Uh, nope. Hmm. I'm going to jump around a little bit. Sorry, guys. New tab. I'm going to go to AP40. Uh, container maybe?
I don't know. It looks like my job is finished. I don't know.
Yeah, okay. So what I wanted to look at, let me find an example because I want to jump around in that a little bit as well. Container singularity image maybe. So in this log, so when you run your job, you get a .log file, right? And a lot of that stuff is just crazy gobbledygook. We usually look at it because we want to see the resources that we used. But if you look a little bit further up in this file, it will tell you what it's doing with the container. So it will say something like this, using singularity image, right? So it copied it, and then it says, I'm using this image, and that's what we're looking for. So is that what you see in your job?
Yes, I see this this message here.
All
Prepare
right,
job and
perfect.
yeah, yeah.
All right. Um, let me see. Okay, so one of the things that I want to point out here is that um, sometimes people are overwhelmed by creating the first container. This is something that we are really happy to help you with. So if you are struggling with that, we help you create this first definition file, right? So we'll help you create this definition file and then hand it over to you, and then you can use that over and over again. So don't get stuck on this step. It's also a common one that we handle in office hours. So if you want to talk to people about it, just show up to office hours or open a ticket. I am going to leave you with a link. No, I have to find that. Sorry. Uh, where is it? Um, mm, okay, so not sure, but okay here. All right, so this link I'm putting here, this is a feedback form. If you have any feedback on this training, feel free to use and we can improve this for next round. And I will be staying around here for another 20 minutes or so. So keep those questions coming. Yeah, I'm glad.
Yeah, so my question is, this is I did this tutorial with you, and it looks like very useful and cool. Here on your cluster, like AP40, but can I do it on some other cluster? Do I need something to like I need Apptainer to do this or?
Yeah, and what you will see, so let me log into something else here. Actually, let me see. We can use somebody else's machine just to show what happens. Uh, so this is an Access machine. Um, if I can log in, let's see. Okay, so don't worry about all this gobbledygook. I want to get a shell. Where is it? Uh, right. So now I'm on a cluster uh, at SDSC, San Diego Supercomputer Center, right? And a lot of these machines, this is a HPC cluster. A lot of these systems, they might not have Apptainer installed in the system location like we do. So on our access points, the AP40, 41, and so on, they just in your path already. What you might find on some of these HPC centers is that they use something like modules or something else to load it. So you might have to do module spider or search for a Singularity or Apptainer. And most of them have, one or two versions that you can use. So then you do module load, right? And now I have, this is a Singularity, but it's the same as Apptainer, right? So now I can do shell or whatever I want to do here. Does it make sense? So the trick is that it might not be in your environment, but modules are usually where you can find this stuff. Right, so Apptainer Singularity are equivalent. They're probably so similar that you should be able to build in one place and use it in another place. The containers that we build on the OSPool are not OSPool specific. If you run on your campus cluster and you run on OSPool, you can use the same container in those places. Okay?
Yeah, thank you so
Other
much.
questions?
Yeah, and
Yeah.
yeah, really want to say that is amazing the way you explain very nicely.
Good. Thank you. Yeah, so this video will be available. It will take a week or so, but it will be in our training materials. And if you want to go back and look, the slides are always available with that link that we gave you. And again, I will stop the recording here. If you have more questions, you can feel free to hang out and ask them. I'll stop the recording. Thank you for attending.